climate crisis. The climate crisis is a severe issue, particularly for future generations. I'll explain what the future holds for us in this video. Let's start by taking a look at the history in the present. Then you will have a clear overview. We start with the past, really the beginning, the previous climate. Through paleoclimatology, we can travel back millions of years. The investigation of climate using soil-based data. Data from sediments on land and in the sea, as well as fossils that date back millions of years. Tiny bubbles in ice sheets tell us that there is a lot of information there. Fossils have historically been utilized to obtain climate data. This is predicated on the reality principle, which states that preferences and needs that a species has today were likely also present in the past. It is implicitly assumed, for instance, that certain traits have not evolved during a species' existence. For those who commented, as you put it, the environment was constantly shifting. Therefore, why even bother? It is because we know past events and the information we have attained. Let's move on. Keep your attention. This is where it becomes essential. We look at climate change quickly from the point where everything begins. The Industrial Revolution. It began in England around 1750. The steam engine was the result of a series of inventions by successively Dennis Papin, Thomas Savery, Thomas Newcomen, and John Calley. Up until 2100, that Industrial Revolution will continue. That goes by quicker than you anticipate. That is 1 second in terms of Earth years. Before going further, let's look at the earlier climatic variations. For instance, it was tremendously hot when the world formed from oceans of lava at the very beginning. Even a planet entirely covered in ice due to the extreme cold, along with everywhere in between, where the temperature was occasionally 10 degrees warmer than it is now. Additionally, there was a time when there weren't really any oceans. It was primarily made up of lengths of dry, arid desert. There was also a time when most of the Earth's surface was covered in water. In contrast, there was essentially no land, and it was much hotter than it is now. The latter is a good illustration of what transpired when ice caps were melting on Earth. A geologic epoch is the name given to each of these times. A map of that exists. We are now living in the Holocene period. Significant biological changes occur every time an epoch changes. Extinction of certain species and the emergence of others. There have been instances of sudden changes, such as the meteorite impact in Mexico. This wiped off every dinosaur on this planet. The 66 million years ago crash that wiped off the dinosaurs was the most disastrous day in the history of Earth's life. Near the town of Chicxulub, off the coast of modern-day Mexico, a meteorite with a diameter of roughly 10 kilometers produced a mass extinction that wiped out more than 75% of all species on Earth. Unimaginable earthquakes hooked the crust of the Earth. North American coastlines were battered by tsunamis with waves over 50 meters high. Forest fires started hundreds of thousands of miles away from the impact location due to the intense heat produced by the first impact and the accompanying flood of debris. Numerous locations around the world still bear the scars of this calamity. However, at a unique place in North Dakota, fossilized fish that perished less than an hour after the impact have been found to provide crucial information. This catastrophe completely destroyed life on Earth on a spring day. Let's look at the last millions of years of Earth's history, known as the Pleistocene, before moving on to the present. There was frequent ice age in it. It was an ice age or not, and all the time. Just a factoid. We are still now in the cycle of the ice age or not ice age. That is a predictable natural cycle that has to do with where the Earth is about the Sun. Its separation from an orbital path around the Sun. We state this because of a current event. Usually, Earth takes around 10,000 years to move an ice barrier retreating. The rate at which ice caps are melting now, assuming that the temperature remains constant, is actually a lot faster. The sea will soon follow. Now it accelerates around 2 or 3 times faster than usual. All of this is man's fault, using coal, gas, and oil. Fossil fuels are hydrocarbon compounds formed from the remains of plant and animal life in the Earth's geological past, especially in the Carboniferous, but also from the other areas. They include petroleum, natural gas, coal, and lignite. Peat extracted from bogs and low moors are also products in this range, though they have yet to be exposed to the extremes of pressure and temperature deep in the Earth's crust that led to the formation of coal, oil, and gas. In addition to hydrocarbons, most fossil fuels also contain sulfur compounds. Fossil fuels are formed by decomposing remains of organisms, including phytoplankton and zooplankton, that have sunk to the bottom of the sea or lake. Millions of years ago, this decomposition process was initiated by bacteria under anoxic or low oxygen conditions. Since humans have been on the planet for 1 million years, CO2 levels have risen and fallen with the ice ages. Because of those emissions of the human epoch, we got out of there, and there's a big spike. We release 45 times as much CO2 as all currently active volcanoes combined. The term Anthropocene would describe the new era that would have resulted from all of these human-caused climate changes. We are currently in the present tense, the human epoch. What to do next? At the climate meeting in Egypt, that is what is being discussed. There are promises made in the Paris Climate Agreement in which we are participating, including China and the United States. The agreement's main objective is to keep the increase in the average world temperature to around 1.5 degrees Celsius. It is currently 1 degree warmer than before the Industrial Revolution. The warmer it gets, the more catastrophic the consequences. Every tenth of a degree counts for the future. The current warming of over 1 degree cannot be reversed, but warming above 1.5 or 2 degrees is still preventable. There is hope, because if we successfully limit further warming, the adverse effects will become less severe. For a maximum of 2 degrees, global CO2 emissions would have to start falling rapidly and reach zero well before the end of the century, for a maximum of 1.5 degrees to zero already about halfway through the century. Moreover, it is necessary to start taking CO2 out of the atmosphere and sequestering it. Emissions of greenhouse gases other than CO2 must also be sharply curtailed. Indeed, at the moment, things still need to get better. We still burn a lot of fossil fuel sand. There's a lot of logging and mostly illegal logging. Thank you for watching this particular video. Now, do you guys find this interesting and want to see this more often? Please comment in the comments so we know. It takes a lot of time. See you next time.